on this problem, there's one important thing you need to know, and that methane is this is the formula. Okay, when we start looking at this one and deciding how to approach it, the first thing I would do is say, okay, I have a balanced chemical equation. That means I might be doing stoichiometry. And then I see I have a mass of the reactant because it tells me the natural gas is methane. So it's this. And then I want volume of water produced. So you notice that the water is gaseous, so this is water vapor. And I want the volume of it, which is probably in liters. But I know I can get to the amount of water vapor using stoichiometry, because I can go between any reactant and any product using the coefficients. Let's see what else I have. I know that my water vapor is at and I know its temperature. Okay, so first of all, I'm not doing anything to the gas, like heating it or cooling it. I have a balanced chemical equation, so that's probably stoichiometry. And the stoichiometry will allow me to go from moles of CH4 to moles of water. Okay, so I have this amount given, so let's do that. I have this reactant. Let's do stoichiometry to get to how much water. Okay, and then the other thing, I'm just thinking ahead, is that when I get the moles here, because I know I can, I'm going to probably be using Pivnert, the ideal gas law, to get to volume. I have the pressure and the temperature, I know R. I can get to moles using the stoichiometry, and then I can solve for volume, and then I'll be done. But you notice that I don't have to go to grams of water. When I use the stoichiometry, it will give me moles of water, and that's what I need for this equation. So let's start with that stoichiometry. I need to get to moles, and so I'll be using the molar mass to get to moles, like you always do in chemistry. Go to moles, and then you can use the coefficients to go to a different substance. But I need to get to grams first, and this is and here I need a molar mass. It's 12 plus 4, it's 16. And those are 0.0, so. Okay, then once I get to moles, I can go to moles of what I'm interested in. I'm interested in water. And this is where I use the coefficients. This is the step that's stoichiometry. I can go, so the coefficients are the numbers in front. That's a 1. This is a 2. So a 2 for the water, 1 for the. Okay. And then a lot of times we would go to grams, but we don't need to, because we're going to use it in that equation there, and that is moles. I'm carrying extra digits just so I'm not rounding with each step. Okay, and then with this equation, I need to think about units. So now I have N, I can solve for V, but I need to think about the units to put into my ideal gas law. So let's look at all of the units. Okay, I have temperature, okay, and then on that sig figs, I really only have 3. On the pressure, three sig figs. We treat the 760 as though it's exact. So your sig figs come from the millimeters of mercury. Okay, and then am I ready to plug in? I have pressure, temperature, R, moles. To solve for V, I'm dividing both sides by this. And this side it cancels. This atmospheres cancels with that atmospheres. This mole cancels with that mole. This K cancels with that K. And the only unit left is liters. And I should have 3 sig figs in my answer. I've carried extra up till now. And it's a huge volume, but remember we were starting with kilograms worth of the natural gas.